Okay, let's kick off this explainer with a riddle. It's really the ultimate catch-22 of modern smart manufacturing. How exactly do you share data across an entire industry without actually sharing your raw, highly sensitive data with anyone? I mean, it sounds literally impossible, right? But solving this exact puzzle is absolutely crucial to unlocking the next generation of industrial intelligence.
So here's the situation. Industry 4.0 and these incredibly advanced smart factories desperately need shared data to survive and actually train their AI models. But sharing that data, that exposes factories to terrifying cyber threats. We've all seen the massive headlines about devastating attacks on industrial networks. Think Stuxnet, WannaCry, Triton. Add to that a complete lack of trust among competitors. Because honestly, why would any manufacturer just hand over their proprietary operational secrets to a rival? They wouldn't. So they lock it all up in silos, which totally starves the AI of the very information it needs to learn and grow.
Well, welcome to today's explainer, where we're going to uncover how two completely distinct, cutting-edge technologies are teaming up to form this incredible synergy to solve this massive problem. We're looking at the ultimate power couple, blockchain and federated learning. Here is our quick roadmap for today. First, the smart manufacturing catch-22. Second, enter the power couple. Third, the 7-step workflow. Fourth, real-world manufacturing impact. And finally, trade-offs and future fixes. Let's dive right in.
All right, Section 1. Enter the power couple, solving that catch-22.
First up, we have federated learning, or FL for short. Think of this as the secure, super smart brain of the operation. FL is a decentralized approach to machine learning. It basically allows a bunch of different participants, say several small and medium manufacturers, to collaboratively train a shared AI model. And the absolute genius of this? They do it without ever exchanging their raw data. All that sensitive proprietary information stays entirely local and private right there on their own edge devices. They are literally only sharing the mathematical model updates, not the raw data itself.
And then, second, we have blockchain. Now, you probably know it from cryptocurrency, right? But here, it acts as our decentralized trust framework. Because think about it, even if federated learning protects the raw data, how do you know a competitor isn't quietly feeding the AI poisoned or fake model updates? Well, blockchain makes sure everyone plays by the rules by permanently recording every single model update on a totally transparent, tamper-proof ledger.
So what you get is this beautiful, continuous loop. Federated learning locks down the data so it never leaks, preserving that much-needed privacy. Meanwhile, blockchain completely eliminates any single point of failure and builds trust among nodes that otherwise wouldn't trust each other at all. Together, they create this highly reliable, incredibly secure AI ecosystem that neither of them could ever achieve on their own. It really is a game changer.
Moving right along to Section 2, the technical how-to. Let's break down the 7-step workflow.
If you want to understand how this life cycle actually works in the wild, you start at the foundation. Down at the bottom level, you've got your local factory clients doing all the heavy lifting and computing entirely in-house. Then, the workflow travels up to an aggregation layer handled by miners, and finally all the way to the on-chain smart contracts running in the blockchain layer at the very top. It's a remarkably well-structured hierarchy. We can really distill this whole complex architecture into a clear, repeating 7-step process. First, nodes get selected. Second, the factories train the AI model locally. Third, they upload only the mathematical updates. Remember, no data. But then we hit step 4, and this is absolutely crucial: mining and consensus. This is where the blockchain steps in to validate that new global model. It guarantees that no central server can be hacked and no bad actor can poison the AI. Once it's validated, the block is broadcast, the global model gets updated, and the whole shebang repeats, getting smarter and smarter every single time.
Which brings us to Section 3, real-world manufacturing impact, where theory finally meets the factory floor.
The research points to 4 massive real-world applications where this integration is just totally revolutionizing things. First is cybersecurity, detecting threats across the entire industry without ever exposing individual network vulnerabilities. Second is predictive maintenance, literally using insights from dozens of different factories to predict when a machine is going to fail before it actually happens, which slashes costly downtime. Third is supply chain optimization, creating these ironclad, tamper-proof audit trails. And fourth, digital twins, creating highly secure virtual replicas of physical systems so you can make real-time autonomous decisions without worrying about a single point of failure bringing the whole thing down.
And right now, the industry is throwing serious weight behind this. There is a huge prioritization on cybersecurity in smart factories, followed very closely by predictive maintenance. And honestly, it makes perfect sense. In manufacturing, a massive security breach or unexpected machine downtime are pretty much the two fastest ways to bleed millions of dollars. So solving those issues with collaborative AI, yeah, that's top priority for sure.
And the numbers we are seeing are honestly mind-blowing. In supply chain optimization, decentralized networks running this exact framework are achieving greater than 98% predictive accuracy. Over 98%. They are successfully aggregating insights from manufacturers, suppliers, and retailers, all while keeping everything totally secure and private.
And down on the actual factory floor, the results are just as impressive. In quality control, these fully decentralized systems are hitting 93% accuracy when detecting damaged packages. And get this, they achieve that level of accuracy in just 8 short training rounds. That's incredibly high accuracy, blazing fast speed, and 0 raw data being shared.
All right, Section 4, Overcoming the Catch-22s. Let's talk about the trade-offs and future fixes.
Now, it's not all sunshine and rainbows just yet. We're definitely still navigating some major hurdles before this is everywhere. We've got data heterogeneity, meaning different factories produce wildly different types of data, which can cause the AI model to drift off course. We've got technical performance issues like scalability and transaction overhead. And of course, organizational barriers, like how do we actually govern this thing and convince people to join in the first place?
The real heavyweight fight researchers are tackling right now is efficiency versus security. Think about a high-speed manufacturing environment, like closed-loop robotics. Those systems require rapid, sub-millisecond latency. A robotic arm simply cannot pause mid-swing to wait for a blockchain to confirm a block. That strict blockchain consensus creates transaction overhead and latency. Now, current permission blockchains can get this down to fractions of a second, which is phenomenal for supply chain audits, but still just a little bit too slow for high-speed, real-time robotic control.
Then there's the human element, right? The incentive problem. How do you actually convince a small or medium-sized manufacturer to spend their expensive computing power to join this network? Well, researchers are getting creative. They're exploring reputation systems, using things like Shapley values and what they call Stackelberg game-based rewards. Essentially, they're building economic mechanisms that literally pay contributors based on the actual quality and reliability of the data insights they provide. You get paid for playing fair and adding real value.
Which leaves us with this final thought to wrap up today's explainer. As we keep optimizing these transaction speeds and perfecting these reward mechanisms, are we finally looking at the permanent end of isolated industrial data silos? Will blockchain and federated learning finally break down these data islands and usher in a totally new era where factories can securely learn from each other's mistakes without ever revealing their secrets? Looking at the data, we are getting incredibly close. Definitely keep an eye on this space because it is absolutely going to redefine how the world builds everything.